So yesterday we looked at probability of certain events occurring and how we can represent them as fractions, decimals, or percents. And today we're going to continue looking at events that could be equally likely to happen. So let's go ahead and read the problem below. Emily and Heather are playing a game of cards. The cards include the numbers 1 through 12. They have then 4 questions after asking 1, what is the sample space? 2, what is the probability of Emily drawing an even card? 3, what is the probability of Heather drawing a card divisible by 4? And 4, are the probabilities equally likely? Well, we've already practiced how to find sample space, which I know is all the possible outcomes that we could have in any of these cards or any situation actually. So I see that in this situation with the cards, they go from 1 to 12. So that means I could draw any number between 1 and 12. So the sample space would be, oops, I zoomed in. 1, 2, 3, 4, 5, 6, all the way up to 12 because all of these numbers are available to be drawn if I just picked a card at random. So this is our sample space. Well, now the second question says, what is the probability of Emily drawing an even card? Well, first of all, what are even numbers? Well, I know that they are like 2, 4, 6, 8. We could also say they are numbers that are divisible by 2. So any number that I can cut in half is an even number. So, for example, this one's even. Oh, goodness, what is going on with my computer? 4, 6, 8, 10, 12. So I want to know the probability of picking an even card compared to the total number of cards. So let's get our fraction prepped. So there are 1, 2, 3, 4, 5, 6 even numbers. And there are a total of 12 number cards. So my probability is 6 over 12. But we also know that we can simplify this fraction to 1/2. Geez Louise, I don't know why it keeps doing this. 1/2, which we also know is the same thing as 0.5 or 50%. So again, all of these numbers are equivalent and therefore we can write them in any way to answer this question of the probability of drawing an even card. Okay, number 3. What is the probability of Heather drawing a card divisible by 4? So first of all, what does it mean to be divisible by 4? Well, it means that I can divide this number, any number, by 4. So I'm only going to focus on the numbers that can be divided by 4. And so I'm going to look very closely with my color here and box numbers that are divisible by 4. So I can't divide 1 by 4 or 2 by 4 or 3 by 4, but I can divide 4 by 4, and I can divide 8 by 4, and I can divide 12 by 4. None of the other numbers can be divided by 4 evenly. So let me write that, divisible by 4 over the total number of cards. So I see that there are 3 numbers that are divisible by 4 compared to 12 numbers total. So again, this is my probability that I can then simplify to 1/4 by dividing both numbers by 3. So it's also 1/4 of a chance of picking a card divisible by 4, which is also equivalent to 0.25 or 25%. And now we are at question 4, which says, are the probabilities equally likely? So is Emily and Heather, are they equally likely to pick their own situation? So Emily drew an even card with 6 out of 12 as her probability. This was Emily. And Heather has a probability of 3 over 12 of picking a card divisible by 4. Are these fractions equivalent? No, they are not. So we are going to draw a line across it saying they are not equal. And we can say the probabilities are not equal. Are not equal. Who has the better chance? Well, Emily does because she has more cards that are even that she could potentially draw than Heather. So Emily is more likely than Heather to draw her situation because she has 6 possible outcomes and Heather only has 3. So let's go ahead and stamp that the sample space of an experiment is the set of all possible outcomes of that experiment. An outcome is the result of a single event happening in an experiment, and the outcomes of an experiment are equally likely to occur when the probability of each outcome is equal.